three test review. So number one is 2n raised to the 1/4 power. Only n is it's 2 times n, and n is the only thing being raised to the 1/4 power. So this could be 2 on the outside, and we're going to convert this to radical form from exponential form. So the exponent is 1/4. We're going to be radical, and it's going to be the denominator is 4 to 1/4. It's n to the first power, which we just leave the 1 off. So it's 2 times the 4th root of n. Number 2, in parentheses we have 3x. We're raising it to the 7/4 power. 3x is in parentheses, so that's going to be underneath the radical. You can leave 3x in parentheses underneath the radical if you'd like. The denominator is 4, so it's a 4th root. And then x, or the numerator of the exponent is 7, so the exponent here is 7. So we have the 4th root of 3x raised to the 7th power. For number 3, write the expression below in exponential form. So now we have to go from radical form to exponential form. So this is the cube root of 5x all raised to the 8th power. So we have 5x, put that in parentheses, we can raise that to the 8/3 power. 8/3. Exponent of 8/3. Next, we have 8 square root of a, all that in parentheses. So 8 times the square root of a in parentheses. And raise that to the 5th power. Well, in this case, the 8 has nothing to do with the radical. It's multiplied, but it is not part of the radical. So we're going to raise 8 to the 5th power, and then it's times square root of a to the 5th power. So we do 8 to the 5th power, and then let's change a, square root of a to the 5th, to a to the 5/2. So exponential form, it's 8 to the 5th power times a to the 5/2 power. Number 5, identify each expression as equivalent to -2 4th root of 16h to the 12th times j to the 5th times k. First we have 2. We need to simplify this. So we break square root of 16. I'm just going to write the square root off to the side. Square root of 16. So that number we got 2 times 8. Break it down with the trees, factor trees. 2 times 4. 2 times 2. So 16 is 2 times 2 times 2 times 2. So 4 2's. It is the 4th root. So we're going to need groups of 4. So there are 4 2's. So the square root of 16 is going to equal 2. Or a 4th root of 16 equals 2. We have a -2 on the outside already. And then from the 4th root of 16, it's going to equal 2. H to the 12th, there are 12 h's. How many groups of 4 can you make out of 12? 3. So it's going to be h to the 3rd. J to the 5th, how many groups of 4 can you make out of 5? Only 1. So 1 j comes out. So you do j to the 1st or just j. Leaving you with a j underneath the radical.
Attention all students, Ashley Johnson, if you're in the building, please come to the main office. Ashley Johnson, please come to the main office.
Alright, so there are 4 j's come out, 1 j is left over, stays underneath the 4th root, and a k is only 1 k, so that cannot come out. So we have the 4th root of jk. -2 times 2 is -4, h to the 3rd, j, 4th root of jk. So we're matching it up with the answer, and this is answer choice 3rd one. And then also this problem, if you look at the directions, it says circle a box and choose each expression you want to select. You must select all of the correct expressions. So there's more, anytime you hit that, there's more than one answer. So if we look back, look at some of the answer choices. Some of the answer choices have exponents. So we probably can change this to exponential form. So what you're going to do is still simplify the 4 through to 16. So the 4 through to 16 is still 2. So you have a negative 4 on the outside because negative 2 times 2. Or the negative 2 at the very beginning. And then you're going to, instead of it, simplify h to the 4 through to h to the 12, you change it to exponential form. So it's h to the 12 over 4. And it's j to the 5/4 power. And it's k is raised to the first power, so it's k to the 1/4 power. So we have negative 4 h to the 12/4 times j to the 5/4 times k to the 1/4. And that matches up with, it was supposed to match up with one of them. It doesn't. So that would be an answer choice. It should be an answer choice. Moving on. Write the following expression in simplest form. We have 27a to the 9th, b to the negative 12, all in parentheses, raised into the negative 1/3 power. So in the simplest form, what I would do, since it's a negative 1/3 power, you have a negative exponent, move everything that's the base of the negative exponent. Move it to the denominator, make it to a positive exponent, so now it's a positive 1/3. We then need to, I would change it from raising it to a 1/3 to a cube root. So it's the cube root of 27, a to the 9th, b to the negative 12. Then I would simplify that denominator. So the cube root of 27 is 3. Cube root of a to the 9th is a to the 3rd. And b to the negative 12, you're still doing it the same way. It's going to be, you can make up 4 groups of them, so it's b to the negative 4. After you get to this point, we see that you have a negative exponent, b to the negative 4th. We're going to take the b and the 4 and move it to the numerator to make it positive. So you have b to the 4th in the numerator, and we have 3a to the 3rd in the denominator, which matches up with letter choice D. On 3b, we just need to simplify. So we have for number 7, negative 3 times the square root of 32m to the 5th times n times p to the 7th. So breaking this down to square roots, we're thinking we need pairs. 32 is 2 and 16, 2 and 8, 2 and 4, and 2 and 2. Circling all the prime numbers. There are 5 2's. We need pairs with the square root. So a pair of 2's, another pair of 2's. So ultimately, we have the negative 3 on the outside. We get 2 out for a pair of 2's and another pair out for a pair of 2's. There's going to be a 2 left over in the square root, but I'm leaving that for now. There's 5 m's, m to the 5th. How many pairs can you make? 2. With 1 left over, we'll leave that. N is just 1, so we can't make a pair. And p to the 7th, you can make 3 groups of pairs of p's out of 7. Then we have a 2 left over, so let's see, is underneath the radical. M left over, N, and a p. So let's simplify this down. Negative 3 times 2 times 2 is negative 12. M squared p to the 3rd square root of 2m n p. Number 8 is 7 cube root of 378b. Taking 378 down, that is 2 times 100. You guys are telling me right now probably 189. 189 is divisible by 3. So it's 3 and 63. And now I can get the numbers I can do without the calculator. 9, 7, 3, and 3. And it's a cube root, so I need groups of 3. So I see 3 3's. No, 3 3's. threes right here. 3 threes. So 7 is from the beginning, 7 times a group of 3. It happens to be 3. And there's a 7 left over, so it stays underneath the cube root. And then b, there's only one b, so I can't make up the group of that. So the answer is 21 cube root 7b. Number 9, just need to write the equivalent. Where a is greater than 0 and y is greater than 0. You see this? That's just math notation that needs to be written there. It really doesn't mean anything for you, just that it cannot be negative numbers. So you can kind of just disregard that. Break it down. 27 and 3 is 81. 3 times 9, 3 times 3. So 3 times 3 times 3 is 81. It is a fourth root. So a fourth root, you need 4 groups of 4. You have to have 4 threes. So it's going to come out as a 3. There's only one x, so that stays underneath that fourth root. And there's 7 y's. We can make up one grouping, which leaves us with 3 left over. So 3 times y times the fourth root of x, y to the third. Oh, never mind, that's not an answer choice. I led you totally wrong. That is equivalent, just not one of my answer choices. Now that I look at my actual answer choices, they are in exponential form. So, take this fourth root of 81, we know that's 3. And x raised to the 1/4 power, y to the 7/4 power. That would have been a lot, but you guys should have told me. It's so much easier. So that is also equivalent. Number 10. Now they're simplifying. I probably should look here. Yeah, this is actually simplifying. So 32 is 16 and 2. Oh, 16 is not prime. 8 and 2. 2 and 4. 2 and 2. It is a cube root, so I need groups of 3. 3 2's, that'll come out. There's 2 left over, so it stays underneath with the box. And then there is x to the 5th. Cube root of x to the 5th is x on the outside, x squared on the inside. Y to the 8th, there are 2 groups. So y times y is y squared, 2 groups of y, leaving us with 2 left over. So the answer is 2xy squared times the cube root of 2x squared y squared. 3c. Oh, here we go. Simplifying, so it is adding and subtracting. First, combine if you can. There are no like terms here. Number 11, 3 square root of 27 minus square root of 2 minus square root of 18. No like terms. Break 27 down. So now we're simplifying. 3 times 3, so 3 times 3 times 3. 3 times 3 times 3 is 27. It's a square root, so we're looking for pairs. There's already a 3 on the outside, so it's 3 times the 3 from the grouping. And then square root of 3. Minus the square root of 2, that cannot be simplified. And 18 can be broken down to 9 and 2. 3 and 3. So there's a group of 3's. So that comes out 3 square root 2. So simplifying this, we have 9 square root of 3. Like terms is negative square root of 2 minus 3 square root of 2. That's like a negative 1 square root of 2 minus 3 square root of 2 is my negative 4 square root of 2. So the answer is 9 square root of 3 minus 4 square root of 2. Number 12. So let's simplify. Negative is the cube root of 54. 2 and 27. 3 and 9. 3 and 3. It's a cube root, so I need groups of 3. 3 threes. That'll come out as negative 3 cube root 2 minus 16, 2 and 8, 2 and 4, 2 and 2. There's a group of 3 2's, so that'll come out. There's already a 2 on the outside. multiplied by the 2 from the grouping, and there's cube root of 2 left over. And the next one is 3 cube root of 16, so we know that is, so it's minus 3, 2 cube root 2. Some of you are saying, why didn't I simplify right away? Why didn't I combine like terms? You certainly can. Combine like terms if you can right away, it'll probably save some time. Minus 4 cube root 2 minus 6 cube root 2. All cube roots of 2. So let's look at, you have negative 3 minus 4 minus 6, negative 13 cube root of 2 is the answer. 13, which expression is equivalent? So let me look at the answer choices. They look like they're all just simplified. So finding like terms, there are no like terms. So let's break this down. Square root of 50, x to the 5th, so 2 and 25. 5 and 5, there are my pairs. 5 comes out. X to the 5th, that can make up 2 groupings. 2, square root of 2x on the inside. 8, we broke down at 2 and 4. 2 and 2. Minus 2, square root 2. I forgot the x's. X to the 5th, so it's x squared on the outside and 2x on the inside. So we have 5x squared minus, or squared times the square root of 2x minus 2x squared square root of 2x. So in this case, to have like terms, you have to have everything has to be the same with variables and radicals. All the variables and radicals all be the same thing. So I have 5x squared square root of 2x's. I'm subtracting 2x squared square root of 2x's. How many am I going to have left? I'm going to have 3x squared square root of 2x's left. And that's our final answer, which should match up over here, and it does with the 14 combining. So it's just adding and subtracting again. So from last, if you have like terms right away, probably easiest to combine them. 3 times the 4th root of 5 plus 2 4th root of 5. That's going to be 5 times the 4th root of 5. And we have 2 times the 4th root of 4. And then we're going to have to simplify 80. So I'm going to do this off this side. So the 4th root of 80, 2, 40, 2, 20, 2, 10, 2, 5. And it's the 4th root, so there are 4 2's multiplied together will make up 80. So that comes out, so it's minus 2, 4th root, and there's a 5 left over. So I'm looking at like terms. I have 5 times the 4th root of 5, and I'm subtracting 2 times the 4th root of 5. Those are my like terms. Give me 3 times the 4th root of 5, and then there's a 2 4th root of 4 left over, which matches up with D. So that's what's on your test for next class. 3D, moving on. So we're going to multiply first, then simplify. We have 5 times 3 is 15. And underneath the radical, 10 times 12 is 120. K times k to the 5th is k to the 6th. And let's simplify. Square root of 120 is 2 times 60. 60 is 2 times 30. 30 is 2 times 15. 15 is 3 times 5. We have 15 already on the outside. We're going to multiply it by the square root, so there are 2's. We have 2 times 3 times 5, that's going to stay underneath. We have k to the 6. How many pairs can you make out of 6? You should be saying 3. Leaving us with a square root of 2 times 3 times 5, which is 30. So 15 times 2 is 30. K to the third, square root of 30. That's your answer there. 16. You need to have a monomial times a binomial. Square root, or 2 times the square root of 6 times negative 5 square root of 6k. Multiply the outside, so negative 10. Multiply the inside, so 36k. Add it to 2 times the square root of 6 times 2 square root of 2k. 4 square root of 12k. Simplifying each term. Square root of 36. You probably have done this enough. You can break down with the trees, but it's 6 square root of k plus 4 times the square root of 12 is 2 square root of 3, and then there's a k left over. Simplifying this further, negative 10 times 6 is negative 60 square root of k plus 4 times 2 is 8 square root of 3k. They are not like terms because we have just k and 3, just k on one radical, and the other radical is 3k. These are not like terms. So all radicals have to be the same and everything underneath. Number 17. We haven't talked much about this, but you have a binomial squared. Squared means times itself. So you have 2 times the square root of 3x to the 5th minus 2 times the square root of y, all squared. You have to do that twice. So it's 2 square root of 3x to the 5th minus 2 square root of y raised to the second power. So that's, I'm not going to rewrite it again. So you just multiply it again. And now we distribute. Double distribution. Multiply the first two terms. That's 4 on the outside, square root of 9x to the 10th. Adding exponents when multiplying like bases. And then we multiply the first two terms, multiply the last two terms, first and last term. Minus 4 3x to the 5th y. And multiply the middle two terms, so it's a negative 4 3x to the 5th y. And multiply the last. That's plus 4 square root of y squared. Let's take this individually. Now we're simplifying. Square root of 9 is 3. So I have 4 from the outside times 3. Square root of x to the 10th is x to the 5th. Moving on. 4 is on the outside already. Square root of 3, can't do anything with that. Square root of x squared, I can. For x to the 5th, that's x squared on the outside. Square root of 3, there's an x left over, and a y. Next term, a negative 4 on the outside, or minus 4. Again, square root of 3, can't do anything with. X to the 5th, square root of that is x squared with a x left over on the inside. So that's 3x, there's only one y, so that stays 30. The last term, square root of y squared is y. Let's simplify this down. So we have 4 times 3 at the beginning, so we have 12x to the 5th minus, if you notice, these middle two terms are like terms. We have x squared, square root of 3xy, and x squared, square root of 3xy. There's negative 4 minus 4, negative 8, x squared, square root of 3xy. And at the end, you have plus 4y. So that matches up with none of them. Huh. Well, it would be a without x here. Just x, and it's a 18. Let's multiply this out. A little bit easier. 6 times 5, 30. So this is double distribution. 6 times the square root of 5 is 6 square root of 5. Multiply here. Square root of 5 times 5. 5 square root of 5. And square root of 5 times the square root of 5 is square root of 25. First term, 30. It's already simplified. Those two terms, like terms. You have 6 square roots of 5, and you're adding 5 more square roots of 5. You have together 11 square roots of 5. And then square root of 25 is 5. Joining our first and last terms are like terms. 30 plus 5 is 35, plus 11 square root of 5. And that's a well-typed question right there. Moving on. 3E. Monomial in the denominator, so this is a monomial. The monomial is just multiplied by the radical of the base. Multiply the numerator and denominator just by the square root of 5. The numerator is binomial, so 3 square root of 2 times the square root of 5 is 3 square root of 10. 3 square root of 3 times the square root of 5 is 3 square root of 15. And the denominator, 3 square root of 5 times square root of 5 is 3 square root of 25. Now let's look to simplify each term individually. 3 square root of 10. Square root of 10 you cannot simplify because it's 2 and 5, there's no pairs. 15 is just 3 and 5, so there's no pairs there either, so you can't simplify them. Those are not like terms. I have 3 square roots of 10, 3 of them, and 3 square roots of 15, you have 3 of those. You can't combine them. They're different. Square root of 25, though, can be simplified to just 5. So this becomes 5. 3 times 5 is 15. Here you're doing pretty well. And then I see that my coefficients of all 3 terms of mine, I can divide them all by 3. So you divide them all by 3. You get 1, 1, and 5. Rewriting this, we get 1 times the square root of 10 is the square root of 10 plus the square root of 15 over 5. Next, we have a cube root in the denominator, and it's still a monomial. So, but it's cube root, you need 3 of the same denominators to multiply together. So we have one from the original problem times the cube root of 5b. So you multiply 3 of them together. Seems like it's going to be a big mess, but it's actually in the end much easier. It actually works out. So in the numerator, we're going to take 5 cube root of b squared times 5b times 5b. So it's 5 on the outside, cube root b squared times 5b times 5b is 25b to the 4th power. So that's taking both of these and multiplying it to that. Take both and multiply it to 4b squared, which again is just 4b squared cube root of 25b squared. All over. When you multiply 3 of the same cube roots together, it's just what's underneath the cube root. So 2 is from here, and then the cube root of 5b times the cube root of 5b times the cube root of 5b. You multiply in 3, you have a group of 3. So that's just 5b. Alright, let's simplify each term. b to the 4th, you have 25b to the 4th, cube root of it. 25 is just 5 and 5, I can't simplify that. But I can simplify b to the 4th. b comes out, leave us with the cube root of b 25b plus second term, there's nothing I can simplify, it's just 4b squared cube root 25b squared. The denominator is just 10. 2 times 5 is 10b. And looking to see if I can simplify anything. 5, 4, and 10. Nope. Those are, can't divide all of them by the same number, but I have v. I have a v here, b squared and a b in the denominator. Divide them all by b. And you're left with 5 cube root 25b plus 4b cube root 25b squared all over 10. You guys can do this. It's not an easy problem, but you can do it. Play it back again if it's confusing. Okay, 2. Square root in the denominator. Again, it's only a monomial, so now we only have to multiply by 5 square root of 5n squared. Only 2 of them since it's a square root. The numerator is only a monomial, so it's nice. 30, after doing those last couple problems, is much nicer. And the denominator, when you multiply 2 of the exact same things, and it's a square root, you end up with the same thing that's underneath. So square root of 5n squared times the square root of 5n squared is 5n squared. Simplifying the numerator, 30 is broke down into 6 and 5, which is 2 times 3 times 5. No pairs. N to the 4th, square root of n to the 4th is n squared. So you have n squared, square root of 30, times 5n squared. So we can simplify n squared divided by n squared, leaving us with the square root of 30 over 5. Square root of 30 is a number, it is not 30, so 30 you cannot simplify with 5. F. So the first thing you need to do is isolate your radical. So there's a positive 9 on the left side, subtract first. It's square root of n divided by 4 equals 7. Now the radical is isolated, now we can square it. It has to be isolated first. If you don't isolate it, it's just going to be wrong. So square it. If n divided by 4 equals 49, multiply by 4. 49 times 4, 96. And you should check it by substituting in 9 plus 96 divided by 4, and it's got to equal 16. So we do 196 divided by 4, it's 49. Square root of 49 is 7, and 9 plus 7 equals 16, which equals 16. That's good. So that is a good answer. Next, so on the right side, so number 24, the right side, the square root of 20 minus x is already isolated. So the square root is isolated, so we go ahead and square. We get x squared equals 20 minus x. Anytime you get an x squared, as your biggest, a square is your biggest exponent, move all the terms to one side and use the quadratic formula. So add x, subtract 20. It's going to equal 0. So the quadratic formula, we have 1 for a, 1 for b, negative 20 for c. So the quadratic formula is x equals the opposite of b plus or minus b squared minus 4ac. You don't have to memorize this. I will give it to you on the test. So a is 1, b is 1, so negative 1 plus or minus 1 squared minus 4 times a is 1 times c is 20 all over 2 times a. Find this. X equals negative 1 plus or minus 1 minus 80 all over 2. And we get negative 1 plus or minus square root of negative 79 over 2. Never mind, I missed a negative. You guys should have told me that I missed a negative. So that's plus 80, which gives us 81 here. That's much nicer. Square root of 81 is much, much nicer. So we do negative 1 plus or minus the square root of 81 is 9 over 2. So negative 1 plus 9 is 8. I'll break this up. So there's two different answers here. Negative 1 plus 9 is 8 divided by 2 is 4. The other answer is negative 1 minus 9 is negative 10 divided by 2 is negative 5. You should check both those answers to make sure that they are correct. So to check, I'll write into a different space, but 4 equals square root of 20 minus 4. And 20 minus 4 is 16. 16 squared root of 16 is 4. 4 does equal 4, so that's good. So x equals 4 is a good answer. Let's check negative 5. So negative 5 equals square root of 20 minus negative 5. Negative 5 equals 25. Negative 5 equals 5. That ain't right. So negative 5 is, we call that an extraneous solution. So it's a cube root of 1/4 x plus 3. To do a cube root, the cube root is already isolated, so we just raise it to the third power. Cube and cube root are opposites, just like square and square roots. 2 to the third power is 2 times 2 times 2 is 8. Subtract 3. You can either, in the calculator, divide by 1/4, or you can multiply by the reciprocal, 4 over 1, which is 4. And x is going to equal 20. Substituting back in to make sure it's correct. Check. This is not checking your work, it's checking for extraneous solutions. It's 1/4 times 20 plus 3, and that's going to equal 2. Always check at the very beginning. Check from the very, very beginning. So 1/4 times 20 is 5. Plus 3, that's going to equal 22. Cube root of 8 equals 2. Sure does. 2 equals 2. That's good all day long. So x does equal 20. And the last problem, we have 7b plus 2 all raised to the 1/3 power plus 7 equals 12. What I would do is I would convert 1 to the 1/3 power. I would convert that to radical form. So it's a cube root 7b plus 2. And plus 7 on the outside equals 12. So now you should see you subtract 7 first. Getting the radical by itself, the cube root. And we know from the last problem, raised it to the 3rd power is the opposite. Cube root. So 7b plus 2 equals 125, because 5 to the 3rd is 125. Subtract 2. 7b equals 123 divided by 7. 123 divided by 7, just a quick check to see if it works. It's not a nice number, so we just leave it 123 divided by 7. So b is going to equal 123 divided by 7. Should check it. We can. Not terrible. 7 times 123 over 7 plus 2 to the 1/3 power plus 7 is going to equal 12. 7 times 123 over 7 is 123. You should be seeing that it's kind of undoing the steps you just did. So it's 125 to the 1/3 power is the same thing as cube rooting it. So it's cube root of 125 is 5. 5 plus 7 does equal 12, which equals 12, and that's good. So that is the correct answer. Come to class with any questions you have. And yeah, this ABC is going to be on Friday, and that's the 30th. DEF will be next Thursday. Thank you.